Okay, today and for the final part of circular functions, we're going to look at applications. This is a very important skill. Almost every year there is an extended response question involving circular functions on the Tech Active exam at the end of the year. What you need to practice and get good at is being able to identify what the question is asking, what it wants as an answer, what kind of maths you can apply, and whether it's most efficient for you to use your calculator or a by hand approach to solve it. Have a look at our question. So this was a question from the 2013 paper from exam 2. When we start looking at them, I really recommend you do take a highlighter in with you. You can start thinking about what are the important parts. So let's see now. Trig the gardener is working in a temperature-controlled greenhouse. Now that's not overly relevant right now. During a particular 24-hour interval, the temperature in degrees C, so it's important we know how the units of things, is given by this equation, okay? So we've got a cosine equation that we're dealing with. That's good to know. And we've got a domain as well, okay? So for that 24-hour period, where t is the time in hours, there's our other units, from the beginning of the 24-hour time interval. Okay, so let's have a look and figure out what we're needing to do here. State the maximum temperature. So we need the maximum temperature in the greenhouse and the values of t when this occurs. It's a 2-mark question. So that means these would both be answer marks. 1 mark for the maximum temperature, 1 mark for the values of t. So how do we work this out? We've got lots of options. We can think about some of it by hand, we can put it straight in our calculator. There are lots of ways of doing this. This is a cosine graph. We know that our cosine graphs start at 1, our basic cosine graphs follow the following pattern. So here our cosine graph's been translated up by 25 units. So if we're wanting to find the maximum value, we can do that by considering the range. So if I was to think about a range of a circular functions equation, I take the amplitude, which we can see here is 2. So our basic graph would go from -2 to 2, but it has been translated by 25, so we have to add on 25. If I was adding on 25, I would then see that the range is going from 23 to 27. Okay, therefore we know our max temperature is equal to 27. Now it is very important that you put the units, so we do need to make sure that our units are given. It happens at 27 degrees Celsius. Okay, let's now think about the values of t when this occurs. So we know it happens at these maximum points. We know this is a periodic function, so we could determine the values of t by considering the period. But I also, like I told you, using a calculator is an important skill, and if it's quicker to use your calculator, that's definitely what I recommend you do. So let's have a look at a minute at this in your calculator and think about how we would consider this, how we would solve this using your CAS calculator. Move to the calculator. Okay. Now here's our equation. We're wanting to find the max values of 27. That means we want to know where does this value equal 27. Now as we established before, if I was just to highlight this and say interactive equation solve, I would get general solutions. That's not what I want though. I need specific solutions, so I have to include my domain. Within the Math 3 menu, there is a given that sign, so we're wanting to solve this equation. Given that our domain, given that 0 is, oops, sorry, I've clicked something incorrectly there. Given that 0, oh dear, is less than or equal to our value of x is less than or equal to 24. So that's our domain. If we now highlight this, we can say interactive equation solve, and we want to solve this. Notice that when we solve it, we are looking at values. We do need it to be standard and in radians. Okay. Whenever we're solving equations, because our range, we assume it's given in radians because we're not told it's given in degrees. Therefore, we make sure our calculator is in radians mode, and we get answers of 0 and 16. So that is our answer. If we were to do this another way, because there are multiple options, there's lots of ways you could do this, another option could be to sketch our function. Now, if I'm going to sketch this function, I do need to think about what kind of view window I would want. Well, we know that our domain is from 0 to 24. I might make it a little bit bigger just so we can get a fuller picture. I might go from -2 to 26. Our range we worked out before was from 23 to 27, but I'll do it a little larger than our given range. Okay. So we sketch our function. So an alternative way to find this is that we could solve it, and we could say analysis g solve max. And we're getting our maximum values occurring here at where x equals 0 and y is 27. If we click the arrow here, we can go to our next value, which is there, x is 16 and y is 27. So two different ways of using your calculator. This method, the graphical method, would have allowed you to figure out the maximum value too. You could just sketch it straight away, get straight to the answer that we had here. So what we have is the max is 27, and it occurs when t is equal to 0 or 16. Okay? Because we're looking for just values of t, it's not actually asking for times, it's asking for values of t. We don't need to put units on here, but you can if you're not sure. The biggest problem people faced in this question was not reading it properly. A lot of people only answered one part of the question. Part B, state the period of the function of t. So the period, we know we work that out by saying 2 pi divided by our value that is with the t, which is pi over 8. You could just type this into your calculator, make sure it's in standard mode to work it out. Oops, that should be an 8. If we're doing it by hand, this is the same as saying 2 pi divided by pi over 8. We can change the divide to a times and flip this over. Remember, 2 pi can be written as a fraction. It's over 1 when not written. We can cancel our pi's out. So we get 16 hours is our period. Okay? Let's see the rest of this question. Alright, now we're wanting to find the smallest value of t for which t is equal to 26. So that means we want to know when the temperature is equal to 26. That means we would be needing to solve our equation here equals 26. Now, let you in on a bit of a secret here. Well, not really a secret, I suppose, but some additional information. We look at the number of marks. This is only worth 2 marks. Therefore, simply telling us what you're going to solve is worth 1 mark. And then the answer is worth 1 mark. This is tech active. Nobody is expecting you to solve this equation by hand. It's 2 marks as long as you've got 2 pieces of information. So we've got this. Let us then solve this. So let's not solve it by hand when we don't need to. Let's go back to our calculator menu. We've got our equation. Now, rather than retyping this, how about we just highlight this here and drag it down here. But instead of solving equal to 27, this time we want to know where it's equal to 26. And we get our values 8 on 3, 40 over 3, and 56 over 3. We want to find the smallest value for which t is equal to 26, so that would be an answer of 8 over 3. Be careful, it did not tell you to give this as a decimal, so we need to give the exact value answer. Had I have tried to solve this in the graph menu, okay, we could have. We could say analysis, gsolve. I want to calculate. I want to calculate an x value when the y value is equal to 26. And it will do this. The problem is it gives a value as a decimal, okay? 2.66 or 2.7 or however you round it, that is not exact. We must always give our answers as exact unless told otherwise. That's why when we're solving equations, while the graph can be useful to see what's going on, I strongly recommend you solve equations in the main menu, okay? So the smallest value is where x is equal to 8 over 3. Let's come back into our slideshow here. Okay, so the smallest value of t is where t is equal to 8 over 3. Again, it's asking for the smallest value. We don't necessarily need to put in units, but we can. That's it. That's all that's required for the 2 marks. Now we want to know for how many hours during the 24-hour time interval is t greater than or equal to 26. Once again, using your calculator is really useful. So let's pop this into our calculator. In this case, I would recommend graphing it. Okay, we want to know if we can substitute where t is equal to 26, we'll be able to see this graphically. So in our calculator, if we go into the graph menu once again, we can type in where t is equal to 26. And we see here, this is what we're getting, okay? Now we have got this over here, so we'll have a look back in here again. Oh. Okay, so what we're trying to find here, I'll change colours so I don't get this mixed up with the red line there. T is greater than 26 for this section here, and for this section here. Now we need to know what those values are, where that's actually happening. Well, we worked out beforehand that this was 8 over 3, and in our main menu we were also able to work out these 2 values here and here. So let's go back again, and my apologies that I'm backwards and forwards all the time, this probably isn't ideal. But back in our main menu, we'd before worked out x is equal to 8 over 3, x is equal to 40 over 3, and x is equal to 56 over 3. We do need to use exact values. If I was using the values in the graph menu and I wanted to find these points of intersection, it would give it to us as decimals, and that will not allow us to calculate the exact value that we need. This is where the main menu is really important. So we can fill these values in. Let me change colour again, so we're on the, and I've lost my graph, there it is, okay. So this is happening here at the value of 40 over 3, and here at 56 over 3, okay? So we're wanting to know for how many values. Now, there you do need to show some working out. Your working out could be a rough sketch like this with your values labelled, okay? If you were to draw a rough sketch like I've got here, that would count as your working out. Your working out could be to say that we solve t equals to 26 and we get the answers of t equals 8 over 3, 40 over 3, and 56 over 3. But that is only giving you 1 mark. We want to know for how many hours. So to find the time distance between here, between 0 and 8 over 3, so the total time, we can calculate by taking 0 at the time between 0 and, I've lost my E, would be 8 over 3, plus we also need to add in this time period here. How would we achieve that? By taking the larger time, 56 over 3, and subtracting the smaller time, which would give us 16 over 3. So we've got our time range there. 8 over 3 plus 16 over 3 gives us 24 over 3, which is giving us 8 hours as the final answer. So, general advice, pay attention to the number of marks. That will help to determine exactly how much you need to do. Also, make sure you're answering the question exactly what is asked and exactly the right amount of information. This question in 2013 did continue on from here. It was a longer question, but it did start to involve calculus after this, and that's not something we're up to just yet. Thank you for watching.